An elliptical arch is 10 feet wide at the base and 13 feet tall in the middle. We have an elliptical arch. The rest of the ellipse would be like this. My highlighter did not highlight. There we go. So that's the entire ellipse. Oh, bad writing. There we go. So this is the elliptical arch. Assume that the ground is the x-axis. So let's put the x-axis down. There we go. And that the arch is symmetric with respect to the y-axis. So the y-axis goes right down the middle. Okay, that'll help us figure out what the coordinates of the points are and everything else. But specifically, that immediately gets us the center as the origin, 0, 0. In the x direction, if this is going to be 10 feet wide, then the right half is 5 feet wide, which puts this value as 5. And 13 feet tall in the middle, this value, 13. We need to know how far is it from the center to the edges for the standard form, which we're looking for, the equation. We look up the equation standard form. We see x minus h squared over a squared plus y minus k squared over b squared equals 1. And whether that's a squared or b squared, those don't really matter. What matters is that the correct number is underneath the appropriate variable. Okay, with the center being 0, 0, that makes the numerator just x squared and y squared. That's nice. Let's fix that. So we apply the h and k. We still have to figure out the divisions. Okay, well, we know that in the x direction, from the center over to the edge of the ellipse is 5. So underneath the x, in the x direction, we need 5 squared. And from the center to the edge of the ellipse in the y direction is 13. Then we need a 13 squared underneath the y squared term. And now we can change the 5 squared to 25 and the 13 squared to 169. We don't have to. We can call that the equation if we want. There's a follow-up question here. And that is, use the equation to find the height of the arch exactly 2 feet from the base of the arch. Now 2 feet from the base of the arch is right here. It's not 2 feet from the center, it's 2 feet from the base. So if that's 2, then that's 3, because we're completely 5 feet out from the center. So that puts us the information we want, this point right here, over 3, and let's call it h for the height that we're looking for. That's what we want to find. So it is specifically, although it's 2 feet from the base, it's an x value of 3, and we want to know the y value. So this is x equals 3. Find y, essentially. So let's set in our equation, let's plug in 3 in for x. And I used h instead of y, but you can leave it as y if you want. Doesn't matter. You can call it x, but no, don't call it x. We want to just solve for h. Okay, it might be easier in your head if you convert all the numbers into non-exponential form. But to solve for h, this is 3 steps. Subtract the 9 over 25 to the right. And whether you do the work to figure out those fractions, if that's fine, you don't have to. Then we need to multiply by the 169. Nope, sorry. The result would not have a 169 anymore. And whether you have that as 1 minus 9 over 25, or you have it as 16 over 25, doesn't matter. And finally, square root. And we have h equals. Okay. So if we square root 169 times 16 divided by 25, that would be the rightmost version, we get 10.4 feet. If we square root the 169 parenthesis 1 minus 9 over 25, that would be the left version, same answer. In fact, from the very beginning, we could have square rooted 1 minus, let's see, it'd be 13 squared times 1 minus 3 squared divided by 5 squared. We could have let our calculator do all of it and got 10.4. One way or the other, the height 2 feet from the base is 10.4 feet. And that came out exactly 10.4. There was no rounding. However, with the instructions round to 2 decimal places, we should have 2 decimal places. The best answer would be 10.40 feet for the requested 2 decimal place precision. Okay, so if I can get all that on the screen at once. Hopefully that helps you figure out this problem. All right, thanks so much.